Okay, so we are discussing about exploring data with the tables and graph. In this section also, we're going to talk about more graphs, and then some of the graphs are so useful. Sometimes graphs might not be the good idea to take a look to compare things. Okay, so let's go here. So this is our key concept. We would like to discuss different type of graphs, and nowadays it's very easy to create the graph using different technology. For example, the graphing calculator we use for this course. Okay, so the first graph is dot plots, a graph of quantitative data in which each data value is plotted as a point or dot above a horizontal scale of values. Dot represents equal values are stacked. So as you can see here, this represents data 40. This one dot represents the data 40. The value of the data is 40. The second one might be 41, and here you can see that two dot above 50. That means 50 is repeated two times, so 50 50, and then 51 is repeated 1 2 3 4 5 times. Keep going like this. So that represents pulse rates of males. So this is the dot plots. The what is that? So dot plot display the shape of distribution of the data. As you can see here, you can see the shape of the distribution, and it's usually possible to recreate the original list of the data values. Like I mentioned here, you can recreate the data like 40, 41, 50, 50, 51, 51, 51, 51, 51, and you can keep repeating if there are finite number of finite means, of course, the data we're dealing here is finite, but sometimes it could be very huge number of data. So sometimes it's possible to recreate the original list of the data values whenever it's whenever we need it sometime. Okay, that's called dot plots. We have stem plots, which is very similar to the dot plots, but instead of plotting dots, we put the number into two branches, like here two parts. So stem plots represents stem and leaf. This part is called stem and this part is called leaf. Okay, as you can see here, this left side is left side here is stem, and then right side is leaf. So this data is actually 40 40 42 42 5050 5050 5252 5252, and keep repeating like that. So so this stem plots represents quantitative, which is number data, by separating its value into two parts, the stem and the leaf. So you can you can see the shape of the distribution of the data by just looking at the stem plot, and then you can retain the original value. You can arrange the same, this data is sorted. As you can see here, it's sorted, so it's easy to look. It's easy if data is sorted, then you can always say, hey, this is one is the smallest one. Like in this case, it's 40 is the smallest one, and 104 is the largest one. Like 10 2, it means 102 and 104. So 104 is the largest one. Sometime we can use a time series graph. Time series graph represents the graph which display the time. As you can see here, the horizontal axis is that for the time. Like in 1985, this is the value for the data. In 1990, this is the value for the data. So it's a time series. By using time series, you don't have to, you can reveal the information about the time and data at the same time. We can use another type of graph called bar graphs, a graph of bars of equal width to show frequencies of categorical data. So we use the bar graph for the categorical data. The bars may or may not be separated by small gaps. So it shows a relative distribution of categorical data so that it is easier to compare the different category. So whenever we use the bar graph, it's easy to compare the different category. There is another type of graph called Pareto chart. A Pareto chart is also a bar graph, but it's a special type of bar graph for the categorical data, with added stipulation that the bars are arranged in descending order. So Pareto chart, here bars are arranged in descending order. It goes from higher to lower. according to the frequency. So the bar decrease in height from left to right. Okay, so Pareto chart is it also shows the relative distribution of categorical data so that it is easier to compare the different category, and we can pay attention to the most important category. For example, here you can see it's a bar graph for fatal plane crashes, the causes of plane crashes, and as you can see that this has a high frequency pilot error. So we can focus on what is the main reason, and then we can focus on the solution for that reason. Okay, pie chart. It's I think most of you have seen the pie chart. It's just pie, and the we divide the pie into different slices, and based on the different category, there will be different slices for those category. And it's a very common graph that depicts categorical data as slice of a circle in which the size of each slice is proportional to the frequency count for the category. I'm going to give you one example here. So this pie chart shows the distribution of categorical data in very commonly used format. For example, here you can see the very same data we're talking about, plane crashes, causes of plane crashes. As you can see here, pilot error is more, one of the biggest cause compared to other causes. Here it's easy to read. Frequency polygon, this graph, in frequency polygon we use line segment instead of bar. And how do we draw the line segment? A frequency polygon is very similar to the histogram we discussed in previous section, but instead of drawing a histogram, we use the line segment here. And there is another variation of frequency polygon that's called relative frequency polygon, where we can compare the percentage of different frequency polygon. So here this is the frequency polygon for commute time, and this is the frequency. As you can see here, a frequency polygon is very similar to the histogram, but a frequency polygon uses the line segment instead of bars. A graph uses the line segment connected to points located directly above the class midpoints value. So if you remember the histogram from previous section, when you draw the histogram, to pick a point from one histogram, you just pick the midpoint from the frequency of that particular bar, and you just join those points. Like for -8 there is a 1.47 data, the frequency is let's say 6, so it's a midpoint of that bar. So this is the midpoint, and you just connect them by using the straight line. The good thing about the frequency polygon and relative frequency polygon is you can compare two relative frequency polygon of two different the commute time in Los Angeles versus commute time in Boise. Okay, so it's because of relative frequency polygon. Sometimes we use data which might give us fake or not right information. Just by looking the graph, we don't get the correct information. So one of them is non-zero vertical axis, meaning we try to draw a bar, instead of starting at 0 level, we start at some higher level. So that's one of the common deceptive graph involves using a vertical scale that start at some value greater than 0. I'm going to give you one example here. This is the comparison between OxyContin and placebo, and then the percentage here experience nausea. As you can see here, they started at 10%. So by just looking at this two bar, we can say that, hey, this is giving you more nausea. But if you start at 0 level, then you can see that that's there you can see the huge difference, but actually it's 11 versus 24. It might be still huge, but just looking at this one and this one gives you the completely different perception about the data. So you always examine a graph carefully to see whether a vertical axis begins at 0 or some point greater than 0. These are the same data, but drawing technique is different. It's start at 0, it's start at 10. Pictograph. Sometimes we use pictures to to compare things, to present our data, but sometimes pictograph could be decisive. I'm going to give you one example here. Let's say this is the pictograph photograph of US National Security Agency NSA collected phone records. In year 1, the records were 151 million. In year 2, the records are 534 millions. By just looking these pictures, it's it's not the correct information. You cannot say that it's they are not in this scale. So just by looking the picture, you can say that it's a huge, but how huge, you have to look at the numbers. Okay, so here are some observation about the pictograph. You can look at here. By using the pictograph, artists can create false impression that grossly distort differences by using this simple principle of basic geometry. For example, when you double each side of a square, its area does not merely double. So look at just take one square and just double each side of a square, but the area would not double. Similarly, when you double each side of the cube, its volume does not merely double. So these are some principle of geometry. So pictograph could be decisive. So what you have to take from this section is, when we try to use graphs to represent data, we have to make sure that we're giving the right information, and we might have to use different type of graphs which gives the correct information in a simpler way. Okay, so whenever the data sets are less than 20, use a table instead of graph. A graph of data should make us focus on the true nature of the data instead of focusing on some other things like color or size. No matter, if you're trying to create a graph or using a picture to represent your data, focus on data more than some other things. Do not distort data. That's the job. That's the main thing. Construct a graph to reveal the true nature of the data. Do not spend your time to represent something else other than data itself. Okay, so now let's do some examples from this section. Let's say first one. This data represents the height of eruption by a geyser, and this is the data you can see. We can copy this data into Excel or StatCrunch. Now we would like to plot the stem plot. So what is a stem plot? A stem plot is, if you go here and then check the stem plot, for the stem plot you need two parts. The first part is this one, the left side and right side. So we're going to use this data, we're going to copy this into StatCrunch and then after that it's just copied here. This is the column. This data is not sorted, so we are going to sort this data. Go to the data, sort it, and select the column and sort it. What is that? Yeah, okay, yes, now it's sorted. So as you can see here, to create this stem, 3 goes on the left side, 2 goes on the right side, 4 goes on the left side, 0 goes on the right side. So that's how you create this stem plot. So just compare your value in one of this. 3 2 3 0, that means 30 30 32, but that's not right. 32 32. So first one is right for both of them, B and C. Let's go to the second one. 4 0 4 0. So 4 0 0. This is the only one, 4 0 0. So this one is the right one. Okay. Now identify the two values that are closest to the middle when the data are sorted in the order from the lowest to the highest. So look at here. When we sorted the data from lowest to highest, there are 20 data. So there are two middle value, which is 10 and 11. So 63 and 65 are the two middle value. So you can say that, hey, these are 63 and 65 are two middle value when you sort it. So when you sort the data. Let's go to next problem. Let's say problem number 3. The graph to the right compares teaching salaries of women and men at private colleges and universities. What impression does the graph create? Does the graph depict the data fairly? If not, construct a graph that depicts the data fairly. By just looking this graph without paying attention to this number, you can see that the men salary looks like double than women's salary. But if you focus on where they are starting, it's starting at 50,000. So women average salary is slightly less than 60,000, and men average salary is almost less than 70,000, which is not the double. So this is not the right impression this graph is giving us. So let's choose what impression does the graph create? So the graph creates the impression that men have salaries that are more than twice the salaries of women. Yes, that looks right. The graph creates the impression that men and women have approximately the same salaries. No, that's not right. The graph creates the impression that women have salaries that are slightly higher. That's wrong. The graph creates the impression that men have salaries that are slightly higher than that of women. No, it creates this impression that men have double salaries than women. But is that the case? Let's go to the next. Does the graph depicts the data fairly? No, because you see the number. If you compare the number, it's slightly less than 60,000 and it's slightly less than 70,000. So the answer is no. There are two no's. So let's read the first one. No, because the data are two-dimensional measurement. Second one, no, because the vertical scale does not start at 0. So look at here, the vertical scale starts at 50,000. So this is the right answer. Let's go to the next here now. If the graph does not depict the data fairly, which graph does? So now if instead of starting at 50,000, if you start at 0, and you can see that if you start 0 for the women, it should go from up to 50, but this is not the right one. So this one is the right one. Okay. Let's look at number 5 here. Fill in the blank. In a graph, if one or both axes begins at the same some values other than 0, the difference are exaggerated. This bad graphing method is known as, what is the option here? A non-zero axis, pictograph, leveling axis, a histogram. So which one is the right one? It's not histogram, it's not pictograph, it's not leveling axis, it's a non-zero axis, because we are using the non-zero axis. Instead of starting at 0, we are using non-zero vertical axis. So that's graphs. Sometimes it gives you the correct information, sometimes it gives you a wrong impression. Yes.